Good day, everyone. I'm Madde, reporting directly from the 1337 headquarters here in Lund, and you are watching our Wednesday knowledge stream. So we've been wanting to do live streams for quite some while now, but due to different reasons, we've postponed it over and over again. You know what it's like when you have those plans and things come up. But then we all know what happened, quarantine and whatnot. So we felt that we really missed all the knowledge sharing that we did. So here we are, and we have our knowledge stream here for you. And it turns out that you like it just as much as we do. So of course we want to continue doing this. And we love to get feedback from you. So if you have any ideas of a speaker that you want to hear, or if you know some certain topic that you want to hear more about, please just send us an email, drop it in the chat, or write a comment, and we'll look into it. So far, we've had knowledge sharing about mob programming, about ethics in software, about Flutter and progressive web apps, and about web performance. But today, we're going to deep dive into lean code. And with us today, we have Kevlin Henney, independent consultant, trainer, reviewer, and writer. So hi, Kevlin.
Hi.
Hi, how are you?
Pretty good. If nothing else, the weather has turned out nicely.
That's good to hear.
Yeah, this is unusual for Britain. So, well, there's a lot unusual for everybody, but having good weather thrown in is quite nice. So, yeah.
Definitely. I was actually in the UK last year, and I was expecting bad weather, but it was sunny for 10 days, and I was surprised.
Wow. That 10 days that I was not in the UK last year.
That's probably it. So you have written a number of books, among some 97 things every programmer should know, 97 things every software architect should know. And
I
now
contributed to that one, although I didn't write it, but yeah.
Okay, edited, yeah. And now, coming in May, you will release 97 things every Java programmer should know, right?
That's right, yeah.
Yeah. So I feel that I gotta ask the question on everybody's minds here. So why 97?
Why 97? Yeah, I mean, there's a number of answers to this. I mean, the flippant answer is because it's a strong prime. And people go like, that's true. It is indeed a prime number, and it turns out it's a strong prime, but it's not very much used for encryption. Although that's true, it's not useful, and it's not really the reason. The original reason dates back to the origin of the whole 97 Things series, which was with the 97 Things Every Software Architect Should Know. And that was Richard Monson-Hafel who edited that. And that book came about on Bruce Eccles' programming list, so kind of small list, and a bunch of people are a member of, and they were asked for 10 things that every software architect should know for a talk that he was doing. And people came up with so many suggestions. He says, there might be a book in this. I wonder if we can get about 100. But he said, we don't really want 100 because 100 is such an obvious list number when people compile lists. And he says the problem is 101 and 99 look too hard, like they're trying not to be 100. They're too obvious. And he said 97 is the right size, but is not trying to be 100. So that's where that came from. So the number stuck. And so hence the whole series is 97 things.
I see. So if you could only choose one thing that every programmer should know, what would that be? It's a hard question, especially when you have 97 things to choose between.
Yeah, that's a really hard question. I'm going to pick on 97 things. I'm going to pick on one that is not there. So that means I don't favor any of the contributors who contributed to that book or the 97 Things Every Java Programmer book. The one thing I think every programmer should know is that your knowledge is never wasted. I think sometimes people worry that there's always a question of skill, and I've found that nothing that you've ever learned is ever really truly wasted. You can always learn from something that you did in the past. Doesn't matter if you started out working in a legacy programming language on a legacy code base. even if it wasn't legacy at that point, that knowledge will still be useful to you in future years. We're very bad at history and integrating our own experience. So I always try to think, well, actually, everything that's happened to you is probably one day going to turn out useful. You just have to look at it right. So, yeah.
That's some really good advice to keep in mind, actually. I like that. So before we begin, I would like for the audience to get to know you a little bit better.
Yeah.
So I've played a little game with the other speakers that we had called Two Truths and a Lie. So I was wondering if you would like to tell us 2 true things and 1 false thing.
These things, I always struggle with these things. But anyway, I have come up with this. Okay, so here's 3 things. As an adult, so not school, I have performed on stage in a play. I have run a marathon. I have done a parachute jump.
Ooh.
True, one of these is not.
Interesting. I look forward to hearing more about this after your session.
Yeah.
But let's not stall this anymore. For you in the audience, as usual, if you have any questions, please post them into the chat, and I will forward them to Kevlin after the session. But with all that being said, I'd like to hand over the word to you, Kevlin.
Okay, brilliant. Okay, so we're going to talk about lean code. And obviously the most natural way to talk about code is to start off with a nice picture in the Swiss Alps. The only reason this is here is because it leans. It's the only picture I had that I've taken that has anything that obviously looks like lean. So let's talk about lean. Lean was popularized in software development predominantly through the work of Mary and Tom Poppendick. And they published this book in 2003. And since then, lean has kind of worked its way into many practices and many even methodologies. So you've got stuff like Kanban, which is a kind of very much a pure lean approach. And there's obviously debates as to whether or not this is agile, not agile, or whatever. That's actually not a very interesting debate. But certainly there is its origin story suggests that it comes from the same root. And when we talk about things like Scrum, its origins are in lean development. The term lean was adopted in the 1990s. Scrum its origin story dates back to the 1980s. So this Scrum versus lean debate that sometimes people have is perhaps a little misguided. Again, it's a question of history. And indeed, we can see this book, 2003, Lean Software Development and Agile Toolkit. Very much, and it's in the Agile Software Development series. There is Agile is a very broad umbrella, and Lean is a particular philosophy. Now, if we go back to 2001, that's where I first came across this idea, and it was a paper by Mary Poppendick called Lean Programming. And she observed recent work in agile methodologies, adaptive software development, that's Jim Highsmith's approach, and extreme programming have in effect applied the simple rules of lean manufacturing to software development. Now, obviously, we should always be cautious. We should be open to ideas from other disciplines, but we should always be cautious to understand where they do and don't match. I'm very wary of the idea of overusing manufacturing metaphors in software development, unless, of course, you are actually talking about things that are manufacturing, compiling code and building code. That's manufacturing. Writing code is not a manufacturing process. But certainly we can borrow in certain ideas and some certain principles. And Mary said, the results, which we call lean programming, are as dramatic as the improvements in manufacturing brought on by just-in-time and total quality management movements in the 1980s. And she articulated seven principles. Eliminate waste, build quality in, create knowledge, defer commitment, deliver fast, respect people, optimize the whole. And these she distilled from other sources on lean product design, lean manufacturing, and so on, things that are outside the software space. And these kind of like this holy seven, in subsequent books, they've pretty much retained their form, although the names have changed a little bit. But I'm going to do something a little bit different here, because my interest here is I want to look at it from the code and the coding perspective. Not the big picture perspective. I think people often look at lean purely from the big picture perspective. But for a lot of developers, some of these lean and indeed a lot of the agile philosophy that we find discussed feels very distant, very remote from where they are, which is the code phase. They're interacting with the code. And these are all good things, but can we bring these things in to something that is more immediate, less alienating perhaps? Now, although these are described as principles, actually, if you look at them, they're not really principles. They are actually directives. They're telling you to do things. Now, I thought I'm going to reframe these slightly. I'm going to try and focus on goals. I wanted to have 7 goals, which are related to those 7, but let's revisit this. And I want these goals from the point of view of the code and the practices that I bring into the code. So the first one we're going to talk about is value. Rather than focusing on waste, let's focus on the other side. Now, there is a problem with value. Is the word value means different things to different people. You've undoubtedly heard the mantra that you should be prioritizing business value, or you should prioritize in terms of business value, and all this kind of stuff. These statements are mostly hollow. They're fairly empty. It doesn't mean anything to prioritize by business value. It's actually not possible. The best you can ever do is prioritize by estimated business value. It's always an estimation. You cannot know the business value of a feature or a product until after, and sometime after, you have actually included it and people are actually using it. So the first thing we're going to do is I'm going to be really careful with language here, because I think sometimes we're a little bit lazy with it. If you have somebody in your organization, if you have somebody saying we're going to prioritize by business value, you can just clarify with them, it's estimated business value. It's not actually business value. You don't know the business value. But also, of value to whom? Who is the business? The business is not a person. Is it customer value? Is it value to the people within the organization? What is the time horizon of the value? In other words, value is a goal, but it's a goal that we need to ask questions about. Is it a value to a customer in the next week, or is it a value to customers over 1 year? That's a different question. People don't ask the time horizon question. Again, as I say, a lot of business language is very, very sloppy. And as I'm interested in code, I value precision. We really need to, value is important as a concept as long as we clarify it. Otherwise, you end up with this kind of like, idea of, it turns out that value for shareholders is more important. Yes, the planet got destroyed, but for a beautiful moment in time, we created a lot of value for shareholders. So what are the things of value? What are the things of value in the code? There's a lot of code that is not valuable. And indeed, this wonderful observation from the Agile tester, David Evans, your customers do not buy your software by the line. Now, if that's not true, if they actually do buy your software by the line, ignore everything I'm about to say. But when we look at most systems, it's as if they were being bought by the line, because they have so much noise, they have so much code. Is all that code of value? Is it all being expressed? So let's sort of appeal to kind of an architectural principle. In fact, I'm going to go back 2,000 years to the Roman architect Vitruvius. Vitruvius is he's the guy responsible for the Vitruvian Man. You may be familiar with a very classic image that is associated with Leonardo da Vinci of a man spread out, and it's the idea of he's within a square and within a circle. And this is a challenge that Vitruvius set. Is this possible to create such an image? And it turns out Leonardo da Vinci did this, but he did it by offsetting one from the other. Anyway, that's not really relevant. What I'm really interested in here is what Vitruvius said about buildings and building architecture. Things that are constructed, things that are artificially created by human beings for other human beings. This is something that we do in software. And he basically identified 3 qualities that you should have. Firmitas, strength, robustness. Utilitas, utility, is it useful? And venustas, Venus, the goddess of beauty, some notion of beauty or perhaps aesthetics. And I want to focus on utilitas because pretty much software development is characterized by being utilitarian. We build stuff for a purpose. We can, it's either we build a tool to solve a problem that we have immediately, or we are building a product to address the needs or the requirements of a customer. The idea is it's got to be useful, because if it's not useful, then what is it doing? This is a very simple form of value. But when we actually look at real code, real systems, there's a lot of dead code. There's a lot of stuff that is not useful. There's a lot of code that is not of value. I'm not even talking about the simple idea of, is this good? This code intrinsically good? Most of it's dead. Now, people always give me excuses. They always say, oh, it's, deleting dead code. We don't know if people are using this. We don't know. Right. Okay. So this is a really interesting thing. It's as if we have a philosophy for adding stuff, but we don't really have a good philosophy. If you look at all software development approaches, most of them are organized around the idea of adding custom requirements. What about getting rid of stuff? How do we declutter? How do we keep our system alive? And people often give various excuses. And I'm going to say it's not a technical problem. If you think it's a technical problem, look closer. You'll find that it's to do with the people. People are resistant. There's a fear. We don't know what the code is doing. That's interesting. We're going to come to that. The fact that you don't want to delete a piece of code because you don't understand your software system tells you an awful lot about what you need, the work you need to do. We have a product. People are paying for it, but we don't understand how it works. That's very interesting. But I want to point on, I want to rest on something else here. The dead code question. So there is an interesting thing in nature. Biologically speaking, what we have is a concept. Okay, I'm going to give. Here's a big secret. The secret to life is death. How do things survive? How does an organism survive? It survives because the organisms that it is made up of have a life cycle. They are born, they are useful, and they die. And we see this in terms of cities, nations, anything. There is the natural idea of a life cycle. Now, although people talk about software life cycles, they don't really talk about them. They talk about adding things to software. And sometimes they talk about retiring software, but they never talk about, how do I know when I should get rid of a feature? You told me you wanted to add it, but the conversation that people never have is, we're going to add this requirement, but how do we know when to remove it? We're going to add this code. How do we know when to remove it? That conversation doesn't exist. I'm going to suggest that if you actually care about value, that conversation needs to exist. It's built into biological systems, but it's also built into a number of the artificial systems we create. My credit cards have expiry dates. The black plastic that credit card is made of is going to last for thousands of years, unfortunately. But it has an expiry date. That allows the credit card company maneuvering room. It allows it to evolve. It allows it to evolve its technology. There's a lot of reasons they do this. It allows a form of progress. In other words, it allows a form, life is based on many aspects of that progress, but we can also imbue that quality into the artificial systems that we build. What is actually the life cycle of your code? When you're adding a line of code, what's the reason it's there, and under what circumstances would I remove it? Now, some of our programming languages kind of make a nod in that direction, but I find that, so in Java, for example, there's a deprecated annotation. And a number of languages have kind of slowly added this kind of feature. This is not a new idea. I first came across it about 30 years ago when I was reading up on a language called Eiffel. And that had the idea, obsolete, I believe, if I recall correctly, was the key word there. That's an idea that is quite old. I'm sure that Bertram Meyer, the originator of Eiffel, got the idea from somewhere else. But this natural idea of, how do we deal with obsolescence? How do we properly sunset code and features? The Java thing is just a foot in the door. It doesn't tell you how to do it. Even when people have got deprecated things, they still haven't got a clear philosophy of what they're going to do. But this comes to me, it's this question. We keep talking about incremental development. We don't talk enough about decremental development. To find the thing of value, one of the simplest things is to remove the things that are not of value. We need to get better at doing that, and to recognize that it's not a one-off, that it's actually the normal state of flow. We'll come to flow, we'll come to change in a bit. Now, I mentioned, I wanted to separate out things that are of value. Let's talk about the quality aspect. When we talk about quality, what do we mean by this? Now, this goes to the next one, firmitas, in this case. And this is about technical debt. Now, again, teams have got a very they are cautious about this, but there's a lack of clear vision. We're building up technical debt. We have a technical debt problem. We see that a lot, but it's treated by by certainly many developers, but it's much more common in non-technical roles, whether they are management or elsewhere in an organization. It's effectively invisible to people, and we're not very good at things that are invisible, things that are abstract, which is why we use metaphors such as technical debt. But here's the interesting question: where technical debt's not orthogonal. Sometimes people say, "Oh, well, we're not. The product owner will never accept the idea that we need to repay technical debt, or that we've got to manage our technical debt because they keep pushing for features." Now, there's a number of things that I think are worth kind of questioning here. The first is, in my experience, many people have never actually asked their product owner or their managers for this. Or, sometimes people say, "Oh, the product owner will tell us that the customer doesn't want us to clean up the code," or something like that. I'm fairly sure that in most cases people say this, they've never actually asked. And in many cases where perhaps there is a response, that the person has never been asked, has never actually gone to the customer, "Hey, look, we've got a choice here. We can give you the features you want, or you can spend lots of money and waste lots of money over the next year in hidden maintenance costs. So, would you like to waste a lot of money, or would you like that feature now? And would you like that feature now? Or would you like us to have something more sustainable? Would you like a long-term business relationship or a short one where we screw you?" If they had that conversation, I suspect that many of the answers would shift. But we're not very good at having honest conversations. But there's another aspect. One is not about the conversation and the communication. One is much more fundamental. The idea that these are somehow orthogonal, that you have to work on features or you work on. The idea of accumulating technical debt, the idea that it doesn't interfere with features is a pure fantasy. It's how does, if you worked with code, that that's not the case. It's not an either or. Indeed, anybody who's even worked with spreadsheets should be made aware of exactly this issue. So this is not it's not an either or question. The fact that's a matter of education that we need to perhaps help people with. Let's make it real. What are the things that happen if you accumulate a lot of technical debt, if you don't manage it? Well, one of the problems that you're going to find harder is staff retention. People don't like working on sucky code. If they realize that there is a choice, we don't always have a choice in our employment, but if you do have a choice and that is getting you down, then why don't I go somewhere else, which is doing things which are more interesting, newer, and more exciting, or they have a better development philosophy? So staff retention immediately becomes, that's a kind of hidden cost, but actually it's a real cost. Security. This is one of the more interesting ways of motivating concern over quality, and it relates to something I said before. The idea, the idea that you don't know what's going on in your code base should be a cause for concern. If somebody says, "Oh yes, we value security, but we have a lot of technical debt," these two statements cannot exist in the same sentence and make sense. Security, and there are problems with security. One of the things about security, we're going to come to knowledge in a bit. The idea, we don't fully understand our code, but it is secure, that doesn't make sense from a philosophical point of view. Security, one of the things based on security is, yes, we know our code, we understand all of our dependencies, we understand all the potential liabilities. There is minimum scope for surprise. We understand what our code is doing and where it comes from. That is what it means to manage technical debt. Guess what? That relates to security. The idea that somebody would say we have unmanaged technical debt and yet we care about security doesn't make sense. They're just covering. Compliance. We have lots of code, but we don't know what it does. But yes, we're still compliant. No, that doesn't make sense either. Do you like spending time working on defects? For some people, they enjoy that kind of puzzle-solving approach. But most of the time, this is not a helpful. This is not helpful at the larger scale. Certainly not. It's not product philosophy. But also, defects have a really nasty statistical profile in time. There are some things that average out nicely, things that have a normal distribution, people's heights, for example, or their shoe size. These are all things that average out. When we come to estimate work, it's not very much a normal curve. It's not a Gaussian. It's kind of a bit skew. Our ability to estimate is slightly optimistic in many cases. It has a long tail, but even that looks normal compared to the profile for defects. Defects, you end up with the idea that lots of defects can be very easy and quick to fix, but some are complete outliers and they will destroy large amounts of schedule. They are unpredictable. Therefore, they're unpredictable and they consume work. They are what is called a risk. Risk is an exposure to uncertainty, and defects are uncertain in their profile. So yeah, you don't want this. If you care about actually delivering features, you don't want to be delivering defects as well. They're kind of strange creatures. Defects often arise through questions of quality. You're going to find development, day-to-day development is going to be harder. Things that somebody could imagine taking a few weeks now take, a few days now take a few weeks. And all these other things. Oh yeah, we want to track markets. We want to be able to track requirements. We want to be able to change our technology. All of these things become harder. So in kind of homage to the previous point about code, there is this idea that when we care about quality, some other aspects of quality, performance. Remember, there is no code faster than no code. We can generalize this. Remember, there is no code cheaper to maintain than no code, and there is no code more secure than no code. All of these ideas, you can see we're heading in a direction where we're actually making good on the word lean. All this other stuff, what's it doing there? It's not of value. Why have we got commented out code? Let the version control remember it has a far better memory. The code base should represent our current state of knowledge. It should represent the things that we know are relevant now. It shouldn't be a kind of like a historical mess. That's what version control is for. So therefore, we need to focus on the value. We need to focus on the quality. This is the product. Inside every large code base, there is a small code base trying to get out. We need to find that. So let's talk about this thing, knowledge, because this is absolutely fundamental. Software development is a knowledge-based activity. What you're doing when you write code is you are codifying knowledge. You are saying, given what I understand about the domain, given what I understand about frameworks, my technologies, the tools that we've got, how my colleagues work, all of this stuff, given all of this knowledge, here is what I think is appropriate in this case. And of course, your knowledge is going to change with time. This also tells us, by the way, what a development process should look like. If software development is about the acquisition of knowledge, the framing of knowledge, and the passing on of knowledge, the retention of that knowledge, then this is what we call learning. This is about learning, and learning cycles. Learning processes have cycles. They revisit. They are cumulative and revisionist. In other words, you don't build everything like magically up front. You are going to work towards your knowledge will improve over time. The first time you do something, you are just learning the basic aspects. What is the shape of the problem? Can I even achieve a solution? The second time you visit that, you know something better. So in other words, we need to account for the fact that our knowledge improves. That should be integral to our fundamental philosophy. The idea that code works and we leave it there in the first random idea we had, that's a terrible idea and denies the strength of what software is. It's changeable. So there is another question about knowledge. How do we get this knowledge out there? If the work that we're doing is the work of knowledge and promoting and retaining knowledge, it can be the smallest thing, a variable name. It could have been A, but on the other hand, maybe, given we're looking at a picture of a mountain, altitude makes more sense. Don't put A and leave it like that. Don't put A comment. This is altitude. Name it altitude. There is stop trying to hit me and hit me, as Morpheus says to Neo in The Matrix. There is this idea of represent what you know. Your tests are sources of knowledge. Wikis, architecture document records, all of these bits and pieces, the very paradigms that you choose, how you choose, why is this in two classes rather than one? That choice of separation is a representation of knowledge. You are organizing your knowledge. But there's something else here about what it means to be a developer. And we keep hearing a lot about 10x developers, and there's various myths around those. it turns out in many cases, a 10x developer is someone who creates code really, really quickly, and 10 more developers have to fix it over the next few years. But I like this more constructive philosophy from Brandon Schwartz. To be a 10x developer, be a good developer who helps 10 other people get better at what they do. Your job is always mentoring, and perhaps you're even mentoring yourself in the future. So therefore, knowledge is no good just held as a secret. You need to communicate. And the word communicate, that's kind of an interesting one. The word communicate comes from the Latin. It's okay. Second lot of Latin today. Sorry about that. Communicare, which I like, because if you try and read that without knowing that it's Latin, you end up with communicare. It is about care. But what I also like is the fact that this word itself comes from the Latin communis, which means together. It's the same as the word community and so on. It is about togetherness. The knowledge is not a secret, or should not be a secret. The idea is that you're trying to create a structure. You're trying to socialize the knowledge. So we have a number of approaches here. This is, I'm going to take this from 97 Things Every Programmer Should Know, piece that Dan North wrote, Code in the Language of the Domain. Pretty much everything you need to know is in the name, in the name of the piece there, Code in the Language of the Domain. And a very simple idea. Let's look at some code. Now, this is the example that Dan uses. And if portfolio ID is by trader id.gettrader.getid.contains key portfolio.getid, and you're looking at that going like, well, I'm not entirely sure what that does. If you know a little bit of Java, you might think, oh, wait a minute, this is probably a map looking up in a map. I've got something like that. But if you look at the names, this is one of the important things. Sometimes when people talk about domain-driven design or using the language of the domain, they think the language of the domain is just the words. As you may know from natural language, language is not just the words. It's the way you put them together. It is their usage. It's how you create a context. If you look here, all of the words are really good. There's only one abbreviation, ID. They're all full terms: portfolio, trader, contains key. Well, that comes from the JDK. All of these are clear words. They are good words. ID is not even a programmer abbreviation. It's actually a real world. If somebody asks you for your ID, that's not a programmer thing. That's a recognized real world abbreviation. So these are all real world terms. But what is missing is we're not actually programming the language of the domain. This is not how people talk about this. This is about a permissions check. Can the trader view this portfolio? This is to do with insider dealing or preventing insider dealing. All that lookup of maps and stuff, that happens inside. But it's not. We're not just labeling. We're not just when you're naming something, you are not just naming methods and variables. You are trying to name the whole. What is the usage? What does it mean? You're trying to establish a context. This is what we talk about knowledge. Don't just think of it in terms of atoms. You need to create the molecules and higher substances that are the code. They represent the knowledge. It's not just these atomic elements. And when we talk about programming features, I think this is quite an interesting one. I find a lot of people have misunderstandings around encapsulation. Perhaps the most common one is that encapsulation is make your data private. That's not it. That really isn't. That's part of it, and making your data private is part of what it means to encapsulate. But I see lots of people making things private and then promptly adding properties that have getters and setters to them, and they've not really made them private. To encapsulate is to put something within a capsule. It is to capture, it is to abstract, it is to try and find out what is this thing. But Michael Feathers puts it rather more sort of convincingly. Encapsulation is important, but the reason why it is important is more important. Encapsulation helps us reason about our code. Now that's really important, because what we're seeing here is it is about reasonable code, quite literally reasonable code. Code you can reason about, not just code that is good and okay. That's the other definition of reasonable. It allows us to think. Knowledge is merely facts if it's passive. Knowledge becomes knowledge by being used, by being connected, by being reasoned about. What we're doing with our code is we're creating a model of reasoning. And it's a model of communication. And that's what we're after. So when you encapsulate, you're not merely making something private. Why are you making it private? You are using it to simplify things. You are using it to offer a mental model to somebody else. And this is one of the hardest things, to get an idea into somebody else's head, but that's what you're trying to do. And everything that we can do to communicate that knowledge and shape it, and of course, the first time we encounter this, we're not going to necessarily get it right. We're not going to perhaps have the best approach, which also tells us that this is why code changes. This is why even if we had no more requirements added to a system, the code could still should still continue changing as we understand what it is doing better and understand how to communicate that. It's not an end in itself. It is a tool for understanding. That's why we care about it. Now, the next thing that's kind of interesting is a lot of stuff I've talked about has been about change. So let's talk about change. Change is normal. And we're not very good at it. I talked about life cycles earlier on. Although we talk about refactoring, that feels sometimes the way that people talk about refactoring is either it's very cosmetic, very much dealing with the surface, or with some teams, when they talk about refactoring, they're talking about whole sprints worth of refactoring, which is almost at the level of re-engineering, which is very much a different process. And in many cases, we get into that particular problem by not recognizing that change is part of what we do. When you add a feature, what is its life cycle? When are we going to get rid of it? Under what circumstances does this not apply? Okay. But also, the first time we do something, perhaps it's not necessarily the best because it was the first time. It's the first time we've had to think about this. It's perhaps the first time we've used a particular framework. But also frameworks change. They get better at doing things. And you look at something and you think, well, hang on, why are we doing all of this when this framework now does it better? So there is this idea. We often end up with, well, here we go. There's a nice piece of legacy. Here's a legacy system. People are not entirely sure what it was for. It's 4,000 years old. And the reason I'm showing it here, because it's a perfect example of a set of monoliths. Monolithos. Yeah, we've moved from Latin to Greek. Monolith is one big stone, specifically one stone that is hard to move. Now, a lot of people say, yeah, okay, let's use the stone metaphor. This is what we want. These are my elegant microservices, my beautifully composed objects, my elegant function call hierarchy with high usage of function composition. Everything's small and neat, and there's an aesthetic quality to it. That's great. And what you end up with is, hey, guess what? This is your microservices architecture. Alan Perlis made this observation. In the long run, every program becomes Rococo, then rubble. We need to be better at this idea that a system starts at this quality and then just drops. We can probably do better than that. We can make specific efforts to improve things, or put another way, specific efforts to put our knowledge into the system to make good on what is there, what we understand. And the things we don't understand, well, we need to focus our attention on those. The things that we understand are not required. Well, what are they doing there? It's one of those questions I sometimes ask people when dealing with multi-threaded code. If you're dealing with multi-threaded code or a multi-threaded system, not all of the code will have multiple threads running through it at any given point in time. So here's the question. How many, if you're looking at a piece of code, how many threads run through that piece of code typically? And there are three answers that are relevant. Many, in which case, this is code that is shared between threads, and we need to make sure that we've done so in a way that makes sense, either through the use of explicit locks, or better, intermediate constructs, or the use of immutable data, and side effect free functions. One thread, well, in which case this is single threaded code. 0 threads, this code is dead. There are no threads that ever run through it. We can get rid of it. This is this idea that we should try and find the knowledge that we have here. And when sometimes the answer is 0, then we know we can get rid of stuff. But we also need to reshape what is there. So a few months back, last summer, I like words and I follow Haggard Hawks, but I completely missed this particular entry until Michael Feathers retweeted it and gave it context, which I thought was lovely. A word for the software architecture lexicon: traumatropism. The regrowth of a plant or tree, often in a bizarre shape or direction as a result of earlier damage or trauma. like a lightning strike. In other words, if we use this, if we look at a lot of software systems, they exhibit trauma tropism. The particular events, maybe, oh yes, this glass is a real nightmare. We just dumped everything in it, racing towards a deadline, and we've never done anything with it since, except try and avoid it, or just kind of keep adding to it with a kind of like a look of fear or distaste as we approach it. And that has now shaped the system. The presence of this class, the presence of particular layers or particularly poorly structured interfaces, then shapes how people then work in future, which highlights a really important idea against this communist aspect. How we represent our knowledge will represent how people think about it. They will represent how people think about it. If you make a simple thing complex, then people will always perceive that simple idea as complex. And they will always approach it with caution, with reverence, and with ritual and lots of boilerplate code. The point is, you can sometimes reframe that knowledge. You can simplify it, and you can get rid of the trauma tropism, but you have to recognize that it is there. Clearly, with physical things, it's easy to do because they're visible in a way that perhaps is not obvious in code. But it's our job to try and make the stuff visible so that we can see the change. So, yeah, there's an interesting observation. How do we normally deal with change? Well, yeah, to be fair, we deal with it relatively poorly. Either we do not acknowledge it, or we over-engineer. And we end up with a smell of speculative generality, where somebody says, we need to make this future-proof. We need to account for the future and how people will change. Well, that's great, but honestly, I've lived on this planet for long enough to know that I'm not very good at predicting how people will change, particularly when it comes to code and requirements and things like that. Oh, there's some things that I can probably put some money on as being safe bets, but most of it, there's always a surprise. The more definite you are about certain things, the more surprised you will be. So assume that you do not know everything. And therefore, that is why we have a lean process, so that we can travel in a relatively streamlined way into the future. Don't add things, remove things. The best future-proof code is the stuff that isn't there. And yet we normally overcomplicate things. This lovely quote from Dan: you have a problem, you decide to solve it with configuration, now you have problems. You've now just created technical debt, complexity, and all these things. And now everyone in future is now going to perceive this problem, this weight, and they have to move this weight around. And the chances are that when you do arrive at the things you want to configure that need configuring, it won't look like your original vision of what needs to be configured. We also get a problem with the evolution of things. That idea, when we release something, now people will depend on it, and now it's almost impossible to change. People have been getting a little bit better at this. People had the idea of beta features and beta releases historically, but now we're getting better at it in terms of languages and libraries, and explicitly saying ring fencing areas and saying this, so in Java you can enable preview features. Features are added to languages. And people have got better at deprecating features in languages, but this idea of preview features and being able to bring things in and allow evolution. Python is probably one of the leading languages in this sense of being able to deal with this idea of like, how do we bring the future to the present and let ourselves experiment with it. But Java has got a little bit better at this, and basically saying, look, here's a preview feature, and if you compile this, strictly, you don't get that feature. But if you want to mess about with it, feel free. But there's no guarantee this is going to stick. So this allows us to soft publish. Okay, this is kind of a lean pub model to features in that sense. We need to get better at thinking of this in terms of, and not just marking things. The term beta has just been overused. It's dead territory. We've destroyed that word. We need to move on to making this idea of a kind of a soft release of features to allow ourselves experimental space, experimental features. There's a lot of different ways of looking at this. And again, changing our philosophy. Write code that is easy to delete, not easy to extend. What I sometimes call the discardability of code. We keep talking about the changeability of code or the extensibility of code, and that can be really complex, and it's not always the right choice. Sometimes the thing we actually need to do is get rid of something. Okay, and this is not like consumerism and plastic. I have a plastic pen here. It's a very simple discardable model. Sadly, the plastic's going to stick around for a few thousand years. Guess what? With software, there's no cost there. We can this should be part of our philosophy. The challenge is not how do I add, how do I get rid of? Again, you can see there's a theme emerging here. Now, we can't predict the future, but there are indicators of areas that we should know to isolate and encapsulate so that we can reason about them in a more stable and clear fashion. And this goes back to 1972, David Parnas on the criteria to be used in decomposing systems into modules. Not exactly the snappiest of titles, but a very influential paper that really gave us a philosophy for how to use modules and modularity in any form, anything as modularity, exhibited modularity. The concept and the explicit terminology of modules have been around since the 1960s. So Parnas didn't invent that, but this idea of what is our philosophy? What are the criteria to be used when we identify modules? And his approach was, we propose one begins with a list of difficult design decisions or design decisions which are likely to change. Now, this sounds a lot like predicting the future, but it turns out that we have many indicators that give us forewarning of these things. How do I know that there's a difficult design decision? Well, you're struggling to make it. Hey, how should we represent this? What persistence approach should we use? If you're having long debates and disagreeing with your colleagues, or you yourself cannot think of any approach, guess what? That's a difficult design decision. You've already discovered it. The very process of trying to explore the solution has shown you where your knowledge isn't. Similarly, if you come up with lots of candidate alternatives, these are also the things that are likely to change. Just because one decision this year was good does not mean that the others that you passed by should be neglected in future. It may turn out that as things change, they become more appropriate. So, structure. Each module is then designed to hide such a decision from the others. So let's talk about flow. That's what we want. We don't want to have these kind of, in our development, we want to have a relatively, we want our days to fit comfortably into our weeks. We want our minutes to fit comfortably into our hours. We want our weeks to fit comfortably into our years and into our broader product life cycles. We want to have a flow. And we are using lots of metaphors now. We talk about that, the build and the deployment pipeline. We have the language of continuity, and this originally started with continuous integration in XP, but these days we talk about continuous deployment. And we work with tools. If you're working in Java, you effectively have continuous. It's called incremental, but you have continuous compilation. Your code is always checked. We need to move to the point where you have continuous unit testing. Your unit tests are always running. That was a feature that Kent Beck included in JUnit Max a number of years ago, but that never got adopted more widely. The idea, we have a continuous flow, that we don't make an explicit point of we stop this activity in order to start the next one. So we're interested in flow. Put another way, sustainable development. At the larger level, this is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Instead of racing towards a deadline and basically tearing up the territory of our code base and racking up the technical debt, we've got to say, well, how do we make this flow? Because yes, I do need to deliver today, but I don't want tomorrow's work basically to be defined by the mess that we made today. How do we smooth the bump? How do we keep on doing this? And this is, again, there's another side observation here, is that we need to move away from project thinking to product thinking more broadly. That project thinking is all about end states and end goals. A project has an end state. The goal is a project can be over. The goal of products is a very different one. If we talk about it in terms of games, the goal of the game is to keep on playing the game. So therefore, how do I keep on playing the game? What are the practices we should adopt to allow us to keep on going? This is not a 100-meter sprint. The sprint vocabulary exists for a reason, but it reflects a very different concept. It's not there because of speed. It's there because of focus and relative speed in a context. The idea when the sprint vocabulary was originally introduced was not that you should be running flat out, 100 meters followed by 100 meters followed by 100 meters. It was simply the idea that developers should be, well, one of them was the developers should be working in a context without interruption. A sprint is focused. There's a straight line there, 100 meters straight ahead. That's my goal. Eye on the prize, no interruptions expected. I don't have to stop at any point and converse with anybody. The idea is you have a goal, it's focused, there's an objective. That's one aspect. The other aspect is that when Scrum came around in the early 90s, when people talked about iterations and iterative development, iterations were months and months long. So they wanted a term that was not iteration, because people, oh yeah, iterative development, I've heard of that. And they'd be thinking a 6-month or a 3-month iteration. They wanted something that was much shorter. That vocabulary, unfortunately, is still with us, sprint, but now people think it's just exhausting and completely not sustainable. Speaking of which, let's talk about this. Move fast and break things. Now, this does not come from Facebook, although I've chosen the Facebook font. It was popularized by Facebook, but it dates back to the 1950s. I'd certainly heard it. I certainly heard it in the last century. It's kind of an engineering maxim. Move fast and break things. Yeah. I mean, that sounds like, sounds like it's got a lot of testosterone there. It's a little bit arrogant. If you're in an experimental space, this is absolutely perfect. The problem is that unless you have explicitly created your software development philosophy and your customers also embrace the same philosophy, this is absolutely a terrible thing. So no, don't. Speed is not what we're after. All of our language, sprint, all the rest of it, this is not helpful. Move slow. You want to move slow and sustainably. You want to move at an easily sustainable pace. Your speed will be over the long term. What happens at the 5-minute level is of less interest than what happens at the 5-month level. People are obsessed with microeconomies, and just like micro optimizations in code, they normally don't help. You want to be able to achieve flow. And again, there's a shift here in vocabulary. We often talk about delivering faster. In fact, the original formulation of this particular item, the idea of deliver fast. No, we should move away from that. We want to deliver sooner, not faster. Faster gets people working in a busy fashion. Sooner is about time. It's not about the nature of their work. It's about when things appear. So in this sense, you're interested in velocity, not speed. Velocity, speed, well, people talk, they talk about team velocity and sprint velocity. They're not talking about velocity, not in the proper physics sense. Velocity has magnitude and direction. Most people are just talking about magnitude. We developed this many story points. Yeah, but were they the right story points? Were they in the right direction? Did we do it in the right way? If you develop by running up technical debt, if you're developing a feature and you're running up your technical debt, then honestly, you're heading in the wrong direction. It's no use heading 100 kilometers per hour north when you need to be going south. You'd be better off walking south. You'd be going faster. So velocity matters, true velocity, not speed. And we need to, again, be careful with our words. And so what we're looking for is something that has consistent rhythm, consistent flow. PDSA, sometimes known as plan, do, check, act. But I prefer study. Study sounds slower. And that's a good thing. You're supposed to slow down. Here's what we're going to do. Now we're going to do it. Now we're going to look at what we've done, and we're going to act on new knowledge or questions that we have, knowledge that we lack. And we can even reframe PDSA. And this exists in the minutes. It exists in the months. We can even understand things like test-driven development, the cycle in TDD, as being a PDSA thing. I write a test. That's my plan. This is what I'm going to do next. I fulfill the functionality, I make it work, and then I take a step back and I study what's going on, what are the trends that I'm observing in the code, what are the trends I'm observing in my tests, what am I not sure about, what am I going to do next? Now, that may be refactoring, but it may be something else as well. So we can reframe this also as questions. What does success look like? What is the simplest thing that could possibly work? Take a step back. Are there any gaps, repetitions, inconsistencies, trends, or questions we have? And how would we address those? So what we're doing is we're setting up a kind of a simple rhythm that is based on questions and answers. We're trying to organize our knowledge, but we're doing so in a way that achieves flow. So guess what? Here's the big secret. Turns out software development is done by people. And although I'm talking lean code here, we have to care about the people, because the code does not appear by magic, and the code is ultimately understood and maintained. We do all of these things in service to ourselves and our future selves. And there's this really good piece by James Grenning in his book, Test-Driven Development for Embedded C. I like quoting this book for a couple of reasons. One, People always say, "Oh, TDD is too hard on our system," or "We're too special." Yeah, there's not much more that's more special than embedded C. So first of all, this is kind of like, yep, here's a fairly hardcore domain. But it's also a lovely definition. TDD is fun. It's like a game where you navigate a maze of technical decisions that lead to highly robust software while avoiding the quagmire of long debug sessions. With each test, there is a renewed sense of accomplishment and clear progress toward the goal. Automated tests record assumptions, capture decisions, and free the mind to focus on the next challenge. This is a really good motivational thing. But honestly, I'm only interested in one thing here. Fancy that. TDD is fun. Are we allowed to talk about that? We normally hide all of our motivations behind the language of productivity, which is productivity is a manufacturing vocabulary. We call people resources. Again, this is like a supply chain terminology. Where's fun? Honestly, when people are actually enjoying themselves and working in a context in which they enjoy, most of the challenges that people perceive organizations having just disappear. So this kind of idea of context, genustas, perhaps beauty is beyond the scope of this talk, but habitability is not. This is a book from Dick Gabriel, published in the 1990s. And he made this very simple observation. Habitability is the characteristic of source code, that it makes a place livable, like home. The biggest, so this is a very simple idea. Your code, you want it to be habitable because you live there. That's another motivation. We need to think of it as a place. It's a model. It's quite literally an architecture in which we live. We also need to be perhaps a little clearer about the group intelligence. This idea of knowledge is important. Knowledge is important. Therefore, we need a good team because we need the best knowledge. How do you get knowledge? How do we express knowledge? How do we refine our knowledge? How do we recover it? And this is what you're trying to do. You need group intelligence to be able to do this. So increasing group intelligence is a goal, but a couple of observations. You don't increase group intelligence just by adding lots of people. You don't increase group intelligence by adding lots of smart people either. There's a little correlation between a group's collective intelligence and the IQs of its individuals. But if a group includes more women, its collective intelligence rises. So this is an observation made from some research 9 years ago, and it relates very simply to this question of diversity. People from diverse backgrounds might actually alter the behavior of a group's social majority in ways that lead to improved and more accurate group thinking. Now, this is interesting because what we're really doing here is we are understanding that if you recruit lots of people who are very similar, with similar backgrounds and similar approaches, then you have a problem because you're not really thinking differently. You haven't increased the group intelligence. You've increased, as it were, in most cases, it is manpower that you apply to a problem. You've got a lot of people that think like you. Well, you're not really thinking differently. If software development is a challenge of group intelligence, then you need to think differently. And that is to do with breadth. It is not simply to do with multiplying the numbers. You need wise crowds. So how do you get a bunch of people to avoid groupthink? You can't just get a bunch of people together. You need to have a number of characteristics. They cannot all think the same. That doesn't mean they have to be toxic and awkward individuals. That's still a problem. They need to be drawing from different, they need to be able to act independently, draw from different sources of knowledge and background, but you also need to put it together again. Now, in respecting the fact that people are people, here's another consideration, one from Hillel Wayne. One of my most controversial software opinions is that your sleep quality and stress level matter far, far more than the languages you use or the practices you follow. Nothing else comes close. Not TDD, not formal methods, not anything. This is, if you have it, the mental health, the general physical health, the health, as it were, of a team, it's going to have a huge difference. All these other things they help. But if this is not addressed, then you're working against the tide. So I'm going to close with understanding how we put it all together, holism. To understand that the whole in many sense is better than is greater than the perceived sum of the parts. Lovely book by Matthew Frederick on actual building architecture. quotes the Finnish architect Elil Saarinen. Always design a thing by considering it in its next larger context. Understand where that code lives. Why is it there? What is it for? How is it used? How might that change? These are the questions that you need, not only to shape the code, but also to be able to come back to it later. We need to be careful again with our vocabulary. We're kind of a little bit loose. I did this search, full stack developer in the United Kingdom, 7,000 results. This was in LinkedIn. Looking for passionate and driven full stack web developers. So passion and drive are different things for a different conversation. I want to focus on the full stack terminology. We've ended up with this very curious, narrow view of the world in some places. When people talk about full stack development, I remember first hearing the term years ago, and it's just like, oh, that sounds like a really cool term. And then as I got closer, I discovered that people were just talking about front end and back end development in a web context. That was their full stack. Now, I thought, well, that's not very full. What happened to all this stuff? You know, I have my background is much closer to the lower part of the stack. All of this stuff, the stack goes a long way down, but the stack also goes up. The philosophy of product development, how we deal with our organizations, our users, society, and ethics. That's the full stack. Yeah, the full stack is really very, very deep. So development needs to go further than the technical stack. The full stack includes the world and the people around the software. And hopefully, when we look at it like that, it basically allows us to reprioritize things by having this big picture view. We can get rid of the stuff and say, well, why is this function here? Why are we building this class in this way? Hang on, we're using this old feature from this old framework, this technology that's actually a high risk. We care about security. Why are we holding on to this legacy that is now out of support? That actually increases our risk. What are our priorities? What is of value to us? So if you like, what we've got here is a way of binding all of these together. And we've got this kind of perspective, which I hope has been useful and perhaps a little more code-centric and keyboard-centric and developer-centric than normal presentations of Lean. So on that note, I'm going to leave you with a nice bit of advertising blurb for the 97 Things Every Java Programmer Should Know book that Trisha G and I have edited and should be out. I think the ebook may be out next month and the hard copy is out in June, but that's something to keep in mind. But yeah, okay, so that's good. Anyway.
Okay, thank you so much, Kevlin.
Very welcome.
It was really interesting. I immediately feel like I need to watch this again. So that's a good sign.
That's a good sign, yeah.
I especially really liked the thing you said about making the code habitable. I haven't thought about it that way before, but
yeah.
It's really
I think that's an interesting thing about that, because I that's a book that I read many years ago, and I know Dick Gabriel, and he's a member of the patents community, and he has some interesting philosophies and approaches to things. It's a thing I read many years ago. It was only when I went back to it a few years later that I felt I fully understood it. And it's just like, wait a minute, this is a space we're creating where we live. And actually, what does that mean for us? And we keep using this architecture metaphor, but we only use it structurally. Architects don't build just for the sake of structure, although there are some architects who do that. The ones we value are the ones that build a place that is livable. It's like we've been missing part of the story of when we use the word architecture. Some of it, you've got to live in it. You've got to live and work with it. What's that like?
Makes more sense now, doesn't it?
Yeah, and it's like a missing piece of the puzzle. Yeah,
definitely. So we did get a few questions.
Cool.
So the first question we got was encapsulation/abstraction. Does that add latency to the execution of the code?
If you do it in a way that adds latency to the code, then yes. If you do it in a way that doesn't, then no. I think that's definitely an it depends question, and this also comes down to the question of costs of abstraction. So I will let me give you an so sometimes people assume that when you wrap things up or you decompose objects, that necessarily you will end up with something that is less efficient in a performance sense. That's not at all the case. Sometimes it may be the case, but it also may not be. And one of my favorite examples was a number of years ago, a company, this was back-end development. They were dealing with a high-performance system where they were storing a lot of data, things like pricing data, news data, and things like that. And they needed a lot of throughput. And they said, "Oh, we care about performance." They were working in C++, but if you looked at a lot of their code, it would be what I would call C+. It's kind of like, yeah, you're using a C++ compiler, but if I look at it, it feels a lot like C. And I asked at one point why one of the codes they were using, so they had all their data had a unique identifiers that ranged from 1 to 17 characters, if I remember correctly. And they kept passing around character pointers, kind of the classic C approach to dealing with strings. And I said, why don't you have a class for this? Why don't you abstract this into a class? Oh, well, we care about efficiency. And I said, well, let me show you what that class would look like. And so instead of allocating things on the heap, you now have a class, because you know the exact constraint of the size, you can now have something that lives on the stack, and you can pass around by copy much more cheaply than having any heap management. Passes around, stacks are optimized. So now you pass the data around. The other thing that I noticed they were doing was they kept recalculating hash codes. Every time they would come to the string, they would calculate its hash code. And I said, when you keep recalculating, it doesn't change. The string is immutable. Why don't you store the hash code? Well, they said, there's nowhere in the char to store it. And I said, well, yeah, of course. But if you have a class, then you have space to store it. So when you create it, you pre-calculate the hash code. You have a structure that is embedded. It's a pure value. And now you can copy it around. It's inline and it's mass. There's a huge performance. We took all of these things that hit the heap, no longer hitting the heap, no heap management whatsoever. All of these little linear complexities, recalculating things, suddenly that becomes a constant time lookup because they had abstracted. When you abstract, when you encapsulate, what you do is you give yourself a point to say, here's a boundary. I can change what's inside the boundary, but this is a concept. It's a first-class concept, and I can optimize the hell out of this. If you leave everything unencapsulated, you are likely to accumulate a lot of accidental pessimizations. But a lot of repetition in code, a lot of repetition in activity. But you cannot easily change the performance characteristics of that code. So my general sense is that encapsulation does not intrinsically bring a cost, and it can, when done appropriately, reduce a cost.
So as usually, it depends.
Yeah, there's an it depends, but we can flesh out what we mean in that space. Yeah.
Okay, good, thanks. The next question was probably asked in context to something you said. I'll see if we can figure it out together.
Let's figure out what the context is.
So the question is, can I see it as a sort of information modeling and term catalog?
Yeah. I'm going to guess this is probably to do with the question about code being knowledge or codification of knowledge. And yeah, I like that way of extending that, because I don't think they think of information modeling as something separate. It's a separate activity. It informs the database and stuff like that. It's like, no, this is an information system. We even use that vocabulary for certain classes of software. We talk about them as information systems. But in one sense, all software systems are information systems. Informatics. This is what it's about. It is about the structuring and decomposition and establishing relationships. And when we apply code, that is also code itself is information. It has structure, and it is itself information. And so, yeah, I think the whole activity, if you consider it to be information modeling, you don't regard information modeling as a narrow activity for database people. It is actually, it's a huge activity that really is, it's everything in one sense. And I think that's a good, really helpful way of looking at it.
Yep, that sounds reasonable. Another question. Is it worth to learn cryptography and blockchain today?
That's a really good question.
Yeah.
So I am not a blockchain or cryptography expert, but I think knowing something about cryptography is useful. Even if it's just very basics, I think it's useful knowledge to have. I think it will always be useful. This idea that everything that you learn you will find useful. Cryptography is filled with encoding forms. It will expose you to different ways. If you've not dealt with it, it will expose you to different ways of understanding software and what you do with it. It will give you an exposure to security. It'll give you exposure to algorithms of certain kind. So all of that's just good stuff anyway, regardless of how you then go on to do it. The more specific question about blockchain is more of a career question. I'm glad that the question wasn't, should I invest in Bitcoin? The answer is, it's just like, really? Yeah, so always keep in mind, Bitcoin is a speculative asset. It is not a currency. People who think it's a currency need to spend a little more time looking at some of the economics involved. It's a speculative asset, which people are trying to fake up as money. It's not a currency. But blockchain is a different thing, and it is a data structure in that sense, and it can be used for a number of other things. As to whether or not you should or shouldn't, I can't say, because I don't know what your other interests are. It has career implications as well. There are a number of companies that are doing interesting things with this. It's not my space, so I can't speak with any kind of authority about it. But if what you need to know is that, then go and do it. If you have time in your hands, and I guess some people have got a little more time on their hands at the moment than usual, then that's not a bad thing. I actually have a blockchain. I have a couple of blockchain videos in my queue that I'm going to watch, because this is something I kind of learn bits and pieces about, but most of them are market hype. I want to see something a little more technical and interesting at the lower level, actually. So I'm doing that because I think it's interesting. I'm not sure it will help me in a broader sense. It's not something I plan to move into, but I think it will help me in a general sense of just, this is a different world and a different way of looking at things that perhaps I have some familiarity with.
It's like we talked about in the beginning, that no knowledge is wasted knowledge.
Yeah.
So.
Yeah. There was actually a really good ACMQ paper last year, a couple of years back. It was quite long, but it was a kind of proper academic look at blockchain and things, and I went through that, and it dealt with things appropriately, and I found that quite educational.
Yeah. Next question: do you have any reading recommendations for project planning, like best practices, etc.?
I think probably most of my recommendations might be considered out of date. When it comes to, I feel like I go through, I pick up advice from different people based on talks, books that I've read, but never any whole book changes how I think about it, except perhaps Tom DeMarco and Tim Lister's Peopleware. I read that when I came out of university, my first job. And that's not really about planning, but it is about trying to understand people. Which turns out to be one of the things you need to care about planning. Actually, no, there is a book I would recommend, because I've just mentioned Tom DeMarco. Tom DeMarco's book, Slack. It's published in 2003. It's a very manager-friendly book. It's not necessarily about software development, but it is structured in but it is such a simple book, and I love it. It really clarified a number of things for me, including things like probability distributions as related to estimates and things like that. It's not a book of how-tos. It's not a book that will give you direct tools. It will give you a mindset that you now go out and say, I know what tools I want, or I need a tool that fits this space, or I need tools, plural. Let's find out which one's best. I found Slack was a kind of like a nice, quick, accessible read that was enough to change the way I approached things. And some of the language I used, again, the productivity-based language, he talks about efficiency versus effectiveness, for example, and that turns out to be quite important. So it's not a book that you'll walk out of, you'll walk away from with a very specific list of here's the things I can now do as when project planning. It gives you a much more holistic view of, like, there are so many different approaches. It's like music. How do I produce music? Well, you can only produce music with a guitar. I'm currently looking at 3 of my guitars at the moment. I'm biased, but my son plays bass. He also plays keyboard. My other son plays drums. It turns out you might need some or all of these. You can produce music with an orchestra. Who am I to say which one is right? And I think there's a certain truth in that for many things. You don't want to appreciate the guitar. You want to appreciate music. So when it comes to project planning, rather than I've learned this one approach, and it may be a good approach, I want to appreciate the world in which it lives. And I think the Tom DeMarco book gives a better view of that.
Yes, I agree. It sounds reasonable. Okay, another question here. Do you have any thoughts on mitigating technical debt in mission-critical systems, like, for example, financing and medicine?
Yes, do it, please. The idea of,
sooner the better.
Yeah. It surprises me. Finance is a little different in the sense that the mission, it's not life critical, it's business critical, but even so, but that does give me a this does the approach, the philosophy is slightly different. Medical systems and say financial systems. So let's talk about medical systems first. These are potentially life critical, directly or indirectly, and the idea of quality is an absolute premium. I'm stunned and sometimes slightly worried when people say, "Oh yeah, we're working on a medical system," and I've done some consultancy and workshops for companies that produce medical equipment and medical related software. I'm always a little bit unnerved when they talk about how much technical debt they have. It's just like, wait a minute, people's lives depend on this. Technical debt is an admission of we actually don't control our code. We don't have a full understanding of what we're building. That frightens me. This should be the one domain where people say technical debt is really not an option. Running it up in an uncontrolled manner is not an option because we are dealing with people's lives. So for me, the first thing to do is to recognize what is technical debt. For mitigating it, you need to get people thinking, how do we think about it and why do we think it's important? If you always have to push people, then you will find that that's not sustainable. So sometimes the trick is to find the right mental model. In the medical space, there's a very clear risk model here. So that should be from the drive for reducing technical debt should come from the organization, should come from the customer. if they actually knew what it was, but it should certainly come from the product owner. It should not be the developer's tool to go to the product owner. In that space, there you need to have the right mental model to do it. Once you have this idea, a clear mental model, like, okay, now we understand why we value reducing it, then you can start saying, and what are we going to do about it? Let's try some easy things. Let's do some code analytics. So Adam Thornhill's book, Your Code Considered as a Crime Scene, is a brilliant example of code analytics. Earlier I said that your code base is a knowledge base. I talked about codification of knowledge. Your code base is a knowledge base, but it also has a history. That history tells you things. Now, if we look at that itself as a source of knowledge, then what are we doing with it? Well, most of the time we're actually ignoring it. We complain about it, or we maybe learn one or two lessons. But because it's in codified form, we can interrogate it, we can question it, we can query it. And that idea of being able to say, well, let's find out what the trends in our code are. Where are the defect hotspots? Where are the change hotspots? These are not mysterious questions. We have the data. Where is the code that changes the most? Where is the code that changes the least? What are the pieces of code that people are avoiding? All of these kinds of questions can be answered there. So in other words, the thing that can help us is by considering all of the assets that we have in the code base to be things that we can look at and understand. And that is going to tell you where to prioritize your technical debt efforts. It's just like, why do we keep it losing? The other way of looking at it, why do we lose time in this code? Why is it taking longer to develop? Why are we wasting our time? Now, that language of assets and waste is actually, if you're looking for the right metaphor in the finance space, you use the language. There's language of investment. There's the language of risk. There are all of these. There's a very strong mental framework. A verbal framework that provides a mental framework for how to reason about this. And we have, why I want a piece of code that can change fast. If we care about changing markets and responding, if the kind of finance we're dealing with is on short life cycles, then this sometimes speaks to us about discardable code. If I'm saying we're going to run a system, we're going to run it for 4 or 5 months, and then we're going to throw it away, then my priorities are quite different to we're going to have a whole load of people working for 4 or 5 years on something. This is a long-term product. So perhaps I should be writing code that's easy to throw away. How do I build a system where I can throw things away rather than accumulate a mass that holds me back? So it turns out the language of economics within that, there's plenty of motivation that we can find, but also it may get us to think about our code differently. It's a different kind of critical to the one that is in the medical space. But it gets us asking the question, what is the context in which this code appears? So sometimes the technical debt is actually we run up a little bit of technical debt, then we throw it away, we write it off. It's as simple as that. That may be the right thing for some systems.
Again, it depends.
Yeah, it depends, and it depends and that's the point, is when somebody says it depends, it's an invitation to find out on what does it depend. Whereas it depends, sometimes people think, oh, well, you're pushing that away. It's like, no, I'm bringing it towards me. I'm interested. On what does it depend? And so it depends is the opening. It's the opening of the conversation you have with your system.
Yeah, it's a good thing to be curious, I think.
Yes, very much so. Yeah.
Do you have any recommendation on how to manage older IT systems?
I don't have anything specific that I can think of above and beyond what I've said. Perhaps building on that idea of the code analytics, gather data. In fact, let me pass on a recommendation I gave to somebody a few years ago when they talked about how they felt very demotivated by their work. They said the code base is terrible. It's an old system. It's a necessary system. That's great. It's always nice to be valued, but it's an old system, and they're looking at all this. Everybody's doing lots of other interesting things elsewhere. And I was reminded of a system that I worked on, very, very long time ago. The code base was in Fortran, not a language that I enjoy. And it was, I found myself feeling really demotivated until I started thinking, well, wait a minute, I can't change all of this. Perhaps it's not for me to change, but I do need to understand it because I need to extend it. And I suddenly reframed it. It was like, well, it goes back to what you're saying about curiosity. What's the thing that's interesting here? It's like we've got it's like we've got something under the microscope here. Let us treat it let us approach it as scientists. Get your white lab coat on. Let's understand the thing. And I found that was my first, my first real exposure to writing my own tools, software tools. Was I need this question answered. Okay, I'm going to have to learn some new scripting techniques and some things. I want to find out, get metrics from the code to give myself views to find out the code structure. So I was building up a little toolkit. That in itself, the act of science here was the most interesting thing. Now I found something, I can do something more directly. And that had some really interesting consequences. I was working with somebody else who had a very different approach to the way that they did their code and would generally take the longer way around. I mean, it might sound like I'm just fooling around writing tools. No, I was finding the thing that was fun, but I got my answers quicker. Whereas I found the other, confusingly enough, the guy I was working with was called Kevin. So Kevlin and Kevin, that makes for confusion. But he was definitely, I'm going to go through every file. I'm going to look at things one at a time. I'll do simple searches. Rather, he wasn't building up a whole image, as it were. Whereas I was trying to find the thing in this that makes it interesting. So sometimes approaching it as a scientist, this is not my code, or rather, it's code I have to change, but it's a given. I did not create the original code. What is the thing that is interesting? And it turns out data is the answer. Let's find out more about this thing. If this is a knowledge base, I mean, I didn't have that vocabulary and way of thinking back then, but let's find out more about this and let's create tools that give us that knowledge. So when it comes to older IT systems, again, most of our knowledge or most of our issues are to do with a shortfall in knowledge. Treat it as an experiment, something under the microscope. How do we get that knowledge? What do we really need to understand? Once you've got that philosophy in place, you may find there's an awful lot more you can do that moves that system into the present.
Okay, we are starting to run out of time a bit. There's still more questions coming, but unfortunately we can't stay here all day, although I wish I could. But I have 2 more questions, if that's all right with you.
That's absolutely fine. But for any questions that are not answered, folks, you can find me on Twitter, and I'm happy to follow up.
Great. So a question we got was, what are your thoughts about testing in regards to lean development? Because to the person who asked it, to them it looked like it locks you down a bit, meaning that you have additional work to do when you try to improve your code.
Yeah, how do you know you're improving your code? So it's just like, yeah, this code is much improved. Yes, but it has bugs. Yeah, but it runs really fast. It's just like, no. It should. The goal here is to move slowly. It's not to move. It's not to move at high speed. Coding is never the problem. Yeah, I've generalized horribly there, haven't I? Writing the code is rarely the bottleneck. I find that when I write tests, I write less production code, simply because I understand it better. The goal is to reach understanding. When I have to test something, it's not. It turns out you can always understand. You can always reach an understanding. I know how to build something, but do you understand how to use it? A test is a usage of it. When you do that, you're increasing the knowledge. The chances are you're also giving yourself the opportunity, and this is the important thing. If you need to change your code, how do you know that you can do so with confidence? That's the fear that normally prevents people from changing things. So for me, the idea of lean development without testing, well, I can give you, I don't know what it's called, but it's not called lean development. It's absolutely essential. And even going back to manufacturing, lean manufacturing, testing is integral to the whole process. That's how you know that it works. Testing is not simply a way of just checking that something works to a certain level of confidence. It is also a way of framing your knowledge. When I write a test, I'm forcing myself into understanding, how do I use something? And this ties in with encapsulation. A lot of people struggle with what I would consider a deeper form of encapsulation. As I said, they just make their data private and then expose lots of properties. It's because they haven't really understood how something is used. They haven't looked at it from the outside. They've looked at you're inside your class looking out at the world rather than being out at the world looking into the interface. I've got an object, it has an interface. How do you use it? And it turns out when you try and build that, you can normally throw things out. You end up with a slimmer understanding, you end up with less production code, tighter interfaces, and as a nice byproduct, you end up with a whole load of tests that allow you to optimize things freely in future. So for me, testing is integral because it keeps the code lean. It gets you to writing less. And there's been a lot of experiments done under lab conditions, but also people have made observations on systems that have tests. Systems with comprehensive unit testing generally are built using less code. Simple as that, because most of the code, the stuff that you don't need, you can get rid of. The stuff that you learn how to do better, you can now optimize more freely and with more confidence. And you end up with a much more precise expression. In other words, it accommodates learning, which I think is fundamental. So for me, my perception of testing is that it is part of this. You can't have this lean code approach without testing. I can't imagine that it would work.
Okay. One last question. Are there any good approaches to put an expiry date on your code?
Oh, that's a really good one. Okay, to-do list. Putting to-do comments is not the way to do it. Okay, let's be very clear about that. I don't think there's a way of doing it in the code, but I think one of the things that there are approaches that are worth experimenting with. Let's look at it from the big picture point of view. If you look at architecture decision records, ADRs, those are becoming increasingly popular. They originated with Michael Nagard about 10 years ago. But it's a really interesting idea of trying to understand the validity of an architectural decision, but also how to retire it. Now, it's not about an expiry date, but he talks about the conditions when you record an architectural decision. You record what it is and why it is that it's like this. That tells you the context in which it occurs. If that context changes, if the reasons for doing this change, then you don't have a date, but you do have a condition under which this no longer applies. And that kind of philosophy, I think, is quite valuable. I'd also put it in code reviews. The idea of when you are dealing with code reviews, that if you follow a checklist approach or even a discussion, it depends on how you do this, but a lot of our code is not new. A lot of the code changes are going back to something that already exists. Use that as an opportunity that should be on your hit list. Has this stuff expired? Do we know something better? So that's not a date, but it is certainly it's a condition, if nothing else. Similarly, look at perhaps adding something to your build that looks at code that's been stable for a long time. and hasn't changed, because that may mean either it's brilliant because you never needed to change it, or it means it's dead. Relate this to tests. So I don't have an easy way of putting an exact expiry date on something, and I'm sure if somebody does find one, that we'll hear about it. But I think it's more a case of expiry condition, and that a mix of review and automation can probably get you there.
Very interesting. I wish we had time for more, but as you said, it's yeah. Please contact on Twitter if they have any more questions. Okay, so I've been giving some thought to your truths and lie.
Yes,
we can't leave that
one question to be answered. Yeah.
So my guess for your lie is that you have not run a marathon.
Oh, good. Well done. Yes, that
but
is.
I don't think you could.
Yeah, it's I've run half marathons, but I have not run a full marathon.
But you have jumped a parachute.
I've done a parachute jump. It was a few years ago. It was my wife. She wanted to do it before her 30th birthday, and I thought, you know what? That's a thing I've always kind of wanted to do. Let's do that. And funnily enough, we were talking about it yesterday, that we kind of think, yeah, we'd like to do it again sometime. So yes, and I have performed on plays, although they've been, you know, nothing that anybody would consider a good play, but and a couple of software conferences that have actually staged plays. I've been part of those, marathon. Although I have, I'm a sometime runner. I haven't been doing much running recently, but yeah, half marathon is my limit.
That's still good. So my longest is 10K. So I'm impressed by a half marathon. So thank you once again so much for taking your time and coming here. It was super interesting, and I hope that everyone in the audience liked it as much as I did, and I think they did. So next Wednesday, my colleague Helen Tomic will tell her story about her team's journey to taking their product from what is a tenant to a full multi-tenant architecture. And personally, I always appreciate the personal story. So I really look forward to hearing it, and I hope that you in the audience do too. So I'll see you again next Wednesday, same place and same time. Bye for now.